Hi, we're Team ArtCloud, and in this video we are going to present our project for INFS3208 Cloud Computing. In the past years, the world's creative industry has been facing critical changes. This is evident in the art and design sector as the ease of technologies and change in societal perspective on the definition of art has led to an increase in self-claimed artists. In the UK, the year of 2018 was recorded as the highest occurrence of artists over the past 7 years, at 67,000 employed and self-employed artists. This movement has led to a tremendous increase in artworks produced globally. In order to manage the booming industry, it is essential to provide a cloud service which supports old and new artists. Our project ArtCloud focuses on providing a cloud-based web application with a database that stores and backs up the artworks of its users on a cloud database. This service benefits the users by increasing the exposure of the artworks to the online community while securing their copyrights and authenticity. Our aim is to create a cloud-based web application that is highly scalable, has high availability, and has a low level maintenance. Here we have included a use case diagram which shows how an artist or art collector may use our system.
During the deployment of the cloud application, we have made some changes to the proposed technologies. In the initial proposal, it was stated that the Platform as a Service Google App Engine would be used to manage the application. As a team, we decided to exchange this for the Infrastructure as a Service Google Compute Engine to increase the flexibility of our deployment. Another adjustment to the proposal was the database service used for the application. Originally, ArtCloud planned to use Google Bigtable and Cassandra. In the development process, this was changed to MySQL, as we realized that a SQL database would be more suitable for our data than a NoSQL service such as Bigtable or Cassandra. We also decided to include the Hadoop distributed file system for our storage, as this storage system is suitable for storing large data sets. HDFS also provides high throughput access to the application data and is highly fault tolerant. The two cloud services used for ArtCloud are Google Compute Engine and Kubernetes Engine. Compute Engine are self-service models for accessing, monitoring, and managing remote data center infrastructures, such as compute, storage, networking, and networking services. Google Kubernetes Engine is a managed production-ready environment for deploying containerized applications. It brings the latest innovations in developer productivity, resource efficiency, automated operations, and open source flexibility. Technologies used to deploy ArtCloud in the area of mockup are Draw.io and Lucidchart because it was simple to use. PHP, CodeIgniter, and Bootstrap was used in the front end due to high scalability and fast builds. Scala was used for backend code as it was compatible with Spark and easy to learn due to its similarities with the Java programming language. Lastly, for our database system, MySQL and Hadoop distributed file system was used as it allows for storing large data sets. This is the time frame for our project deployment.
For application architecture, the computer engine houses 5 Docker containers: master, slave 1, slave 2, MySQL, and PHP. The HDFS clusters link all of the containers together through a file system. We utilize the Jupyter Notebook to access the HDFS to populate the database and conduct data analysis using Spark SQL and Mlib. MySQL then houses all the data, which then is used by PHP to be displayed on the front end. Connection between the PHP and MySQL is established by using the IP address of the instance. Once the connection is done, the CodeIgniter framework allows an easy access to the data as shown in the signed model PHP, the diagram on the right.
For ArtCloud's database design, we have 3 main tables: user, artwork, and searches, all of which have unique IDs. Each user may have an artwork, but every artwork has to have an artist. Each user can also input search data in the front-end search bar that will then populate our search table to be used for data analytics. ArtCloud uses Spark SQL to populate our database, MySQL, through pulling the CSV files from Jupyter from the HDFS. Jupyter then writes the data back to MySQL. Besides populating the database, Spark SQL is also utilized to perform queries on our database. In this example, a query on the average number of likes per user is displayed into a temp view. This table is then saved as a CSV file back to the HDFS. The terminal then shows that Spark SQL successfully wrote data back to the file system, enabling us to perform internal analytics on the data we retrieved. Here we have our files stored in the HDFS.
For our advanced analytics performed on our data, we use the advanced analytics tool Spark MLib for machine learning. In one of our analyses, we use frequent pattern mining on the titles of the artworks to predict text. Frequent pattern mining finds statistically relevant patterns in a data sequence and enables us to predict the occurrence of a specific item based on the occurrence of other items in the transaction. As an example of our application of this, we have 4 image titles including water. In these titles, there are 3 occurrences of color, 1 occurrence of building, 1 of on, 1 of fish, and 1 of flowers. To predict the word accompanied by water, Spark MLib examined the input items against all the association rules and suggested a color, which gives the suggestion of watercolor. In our other analysis using Spark MLib, we use collaborative filtering to suggest artworks to a user based on user searches. Every search by a user is stored in the database, which are compared against each other to suggest artworks. The frequent pattern mining application can be used on our website to autofill searches or suggest titles when a user uploads an artwork, based on the existing titles in the database. The collaborative filter analysis can be used on our website to suggest artworks or generate personalized websites for users based on their search history. This analysis may also be used to generate personalized advertising, and the data stored for this purpose can also be used to create a trending page or autofill searches based on the frequency.
Now we will demonstrate the use of ArtCloud website, which shows the minimal viable product. Our ArtCloud database stores all of the community artwork under the table called Artwork. These community artworks will be shown in our homepage. Now we will do a registration demo. A new user can register for an account using a username, email, phone number, and a new password. This new user account will be saved in our database under a table called user. For the demo, we will sign out and log into our existing user called YoungSun. The user can like any of the artworks on the website. For this example, we can like our work called Abstract Fun by Chen Wei and increase the number of likes to 37. This change will be reflected on our database under a table called Artwork. The user can also go into the My Storage page, which shows all of the artworks posted by the user. So for this user, she has 1 artwork posted by herself. The user can also do a search, which will be shown through a keyword. So the user can search for a keyword called abstract, and all of the artworks containing the keyword on the title will be shown. This keyword will be saved in our database under the table called search. This table will be then used for our Spark SQL for data analysis. In future iterations, we aim to reflect the data analysis done by Spark SQL and MLib in the front end of the application. With new features, The artist can enjoy the personalized homepage or autofill for the search. Thank you for your view.